All right, so let's go over how to write formulas for basic ionic compounds. Now, you already should know how atoms, metals and nonmetals, form ions. You should realize that aluminum atoms are not happy the way they are. They're not stable. They don't have 8 in their outermost energy level. They have 3. That's why there's 3 dots on these Lewis structures here, these Lewis dot structures. So aluminum atoms are not happy. They're unstable. They want to react. They want to fix the problem. Nitrogen is a nonmetal, and nitrogen atoms are also not happy. Why? Because they have 5, not 8. So atoms, unless you're a noble gas, and we're not even going to talk about noble gases in this unit because this is all about atoms that bond, and noble gases have 8 in their outermost energy level, so they don't need to bond. But these metals, those nonmetals, they're going to have to work together. They're going to have to interact with each other so that they can both end up with an octet. They just go about it differently. Metals always lose. They always end up with fewer electrons than they start with. And nonmetals always gain. And you can't really have one without the other. So when a metal and a nonmetal are in a situation where they're close by, they have the ability to transfer electrons from the metal to the nonmetal, they will do it. Aluminum is going to take these 3 and get rid of them. It's going to give them to the nitrogen. And that is going to wipe out aluminum's 3rd energy level. It no longer has 3 occupied energy levels. Now it only has 2. And the 2nd energy level is the outermost, and it's filled with 8, so now it's happy. So aluminum is going to look around for a nonmetal to give its 3 electrons to. And it just so happens to find nitrogen because they're together in the same area. So nitrogen's situation, it has 5. It needs to gain 3 more. It looks over at aluminum and says, sure, I'll take yours. I'll take that one and put it there. I'll take this one and put it there. And I'll take this one and put it there. And then I have 8, and now I'm happy. So we'll fix that little guy. So aluminum loses 3. And remember, if it loses 3 negatives, it's going to have more positives. So it's a +3 charge. Nitrogen gains 3, so it's going to have 3 more negatives. Now notice that this is a 1-to-1 ratio. 1 aluminum made 1 nitrogen very happy. So this is a 1-to-1 ratio. And that means our formula is going to reflect our ratio. Formula is just a count of how many ions you have. So there's 1 aluminum ion. Yeah, 3 valence electrons were transferred, but we're not looking at valence, we're looking at how many ions there are. And you'll see how we go and do more examples, how that becomes obvious. Nitrogen, there's only 1 of them. Yes, it did accept 3 electrons, but there's only 1 of them. You don't need to write ones. I'm going to as I explain this, just so it makes sense and you don't think I forgot something. But when you were writing the formula for aluminum nitride, which this actually is, you would just write AlN. If you don't see numbers there, it's understood they're ones. Just like H2O. If you saw H2O and I said how many hydrogens, you know it's 2. If I said how many oxygens, you assume it's a 1. The 1's not written there. Nobody says H2O1. It's just implied. All right, let's look at the next one. Calcium. Calcium's not happy. It's only got 2, not 8. If it could just find a way to get rid of these 2, then this energy level would be empty. The 3rd one is the outermost. It has 8. Then calcium would be happy. So calcium atoms are not happy. But if there's a nonmetal around who will take their electrons, then they can become happy. So calcium's always looking around for someone to react with, someone to take the electrons. Now, chlorine is a nonmetal, and chlorine is an atom that's also unhappy. Why? Because it has 7, not 8. If it could just gain 1 more, then it would be stable. It would have 8 in the outermost energy level. So let's imagine somebody puts calcium atoms and chlorine atoms together in a container. They bump into each other. They realize, hey, calcium, I want to get rid of 2. Chlorines are thinking, I need 1. So this calcium looks at this chlorine and says, can you take 2 of my electrons? I need to get rid of 2. And this chlorine says, I only have room for 1. I have 7. I just need 1 to get to 8. I can't take both, but I'll take 1 of your electrons. and it becomes a -1 charge because it gains one negative. And calcium says, please try to take the other one. I really got to get rid of that other one. And chlorine says, I can't do that, but there's a lot of us chlorine atoms in this container, and we're all unhappy. I'll go find a friend. So along comes chlorine number 2. And this chlorine takes that electron, and it becomes a -1 charge. Chlorine always becomes a -1 charge because every single chlorine that you have will only gain 1. Meanwhile, calcium has to get rid of 2. So it's going to lose 2 and make a +2 charge because it's going to have 2 more positives than negatives. So if we look at the ratio here, there's one calcium ion that when it bonded, when it interacted, it needed to interact with 2 chlorine ions in order to get rid of both of these. They don't always interact on a 1-to-1 ratio. Sometimes the numbers don't match and we need more. So when we count how many calciums there are and how many chlorines there are, we realize it's a 1-to-2. That is your ratio. That is your formula, 1-to-2. Again, normal people don't write the ones, so we would just write CaCl2. That's the formula for calcium chloride. Sodium. Sodium's got that one little valence electron. Sodium atoms are unbelievably unstable, unhappy. It wants to get rid of that. It can't until it comes in contact with a nonmetal. So enter oxygen. Oxygen atoms are also not happy because they have 6, not 8. They're looking around for 2. So we put sodium and oxygen atoms, unhappy guys, in a container. And the little sodium says, I got to get rid of this electron. And it looks at oxygen. And oxygen says, I'll take it. So sodium gives up the electron. And it becomes a +1 because it lost one of its electron. Now it has one more positive than negative. So oxygen says, well, I need another one. Give me another electron. And this sodium says, I can't do that. Because after I got rid of that one electron, my outermost energy level has an octet. I don't want to mess that up. I'm good. But there's a lot of us sodiums in the container. I'll go find a friend. So along comes sodium number 2. And sodium number 2 hands off its electron to oxygen. So sodium also becomes a +1. Every single sodium always becomes a +1 because they always get rid of one electron. And oxygen gains the 2 more negatives and becomes a -2. So how many sodiums do we have? 1, 2. How many oxygens? 1. It has to hook up on that ratio so all the electrons can work out and everybody becomes happy. That ratio is what your formula is. 2-to-1. There's 2 sodiums for every 1 oxygen. If I was writing this, I would write Na2O. I wouldn't write a 1 after it. And finally, the most complicated that you're going to see, here's magnesium saying I really need to get rid of 2s, so this could be my outermost energy level. Phosphorus is saying I have 5, I really need 3 more, and then it'll be stable. So we've got these atoms that are unhappy as they are, but we put them in a container, they bump into each other, and they realize, hey, we can make this work. Like I said, this is the most complicated of them all. Magnesium has to get rid of 2. It looks at phosphorus and says, will you take mine? Phosphorus says, absolutely, I need 3. So 1 goes there, the other one goes there. And phosphorus looks at magnesium and says, give me another one. And magnesium says, I can't. My 3rd energy level's gone, and now my 2nd energy level is my outermost, and that has 8. I'm not touching that. So this magnesium is all nice and happy with its +2 charge. It's stable, it's good. But this phosphorus still isn't happy because it's missing 1 more electron. It needed 3, it only got 2. So magnesium says, I have an idea. There's a bunch of us magnesiums in the container. I'll go find a friend. So along comes this magnesium, and it says, here you go. And now phosphorus is all happy. It got its 3, makes a -3 charge. Now it has 8 in the outermost energy level. But this magnesium still has another electron to give away. And it looks at this phosphorus, this first one, and says, here, take this one too. And phosphorus says, I can't. I'm not going to go add another energy level with just 1. That'll mess everything up. But I'll find a friend. There's another phosphorus. There's a whole bunch of us in the container. So this magnesium says, oh, great. I'm going to give this phosphorus 1 electron. Now I'm happy. I got rid of both. They happen to go to 2 different atoms, but it's still got rid of it. And then finally this phosphorus says, well, I need 2 more. And this magnesium says, well, I don't have any more, but there's a friend. So here comes the next magnesium. So magnesium always, always, always gets rid of 2. Phosphorus always has to get 3. And the only way to work that out is by having 1, 2, 3 magnesiums react with every 2 phosphoruses. That 3 to 2 is your ratio. That is your formula. Mg3p2. These numbers are how many ions we need to react. All right, in a second, we're going to look at a shortcut, and then we're going to practice a little bit.